Hello, and good morning. Some spectroscopic problem solving. How many proton NMR signal and their multiplicities would be expected in the following compounds and why? This is the ring proton, this is the methylene, and this is the methyl. So three types of protons and three peaks. Predict with reason the multiplicities of the signals in the PMR spectra of the following compounds. Doublet due to one neighboring group, and this triplet due to two neighboring. Doublet, one neighboring, quartet, three neighboring. Label all sets of equivalent protons and indicate how many proton signals in PMR spectra would be expected from the following compounds. Methoxymethane, methyl, this methyl, one types of proton, one peaks. This methyl, and this so three types of protons, three peaks. A, B, C, D. Four types of protons, four peaks. These are same. B, C, three types. Two peaks. A compound has the molecular formula C7H6O2. It gives an IR absorption band. At 1771 per cm on treatment with lithium aluminum tetrahydrogen, it gets converted into compound B, which shows characteristics IR absorption bands at 3330 per cm and 1050 per cm. Assign structure to compound A and B. Tetrahydrogen lithium aluminum is a reagent which reduces aldehydes ketones. Carboxy acid into alcohols. The formula C7H6O2 rules out the possibility of an aldehyde or ketone which contain one oxygen. The compound appears to be benzoic acid with molecular formula C7H6O2. An absorption bands at 1771 per cm of support this assumption. On treatment with tetrahydrogen lithium aluminum benzoic acid is reduced to benzyl alcohol. The absorption bands at 3300 30 is due to aromatic ring and 1050 per cm is due to alcoholic group. Not 300. Give a structure consistent with the following data. Molecular formula C2H5Br2. Doublet at delta value 4.152 hydrogen. Triplet at delta value 5.771 hydrogen. What is the name of the compound? The NMR data shows that two hydrogens in the compound are equivalent and one hydrogen is of different type. A probable structure. There are two types of hydrogen indicated by A and B. Doublet at delta 4.15 is due to methylene protons coupled with methane proton. Methyl hydrogen gives the peaks more downfield because of the presence of two bromines on the carbon carrying this hydrogen. PMR spectrum of the compound shows the following peaks: delta 7.22 singlet 5 hydrogen, delta 3.59 singlet 2 hydrogen, delta 2.77 quartet 2 hydrogen, delta 0.97 triplet 3 hydrogen. In the IR spectrum, there is a strong absorption of 1705 per cm, giving the reason. Find out which of the following structure is in keeping with the above data. IR absorption band is obtained at 1705 per cm. This is the characteristic of a carbonyl group, hence the structure A and C ruled out. Structure A and C. Okay, no carbonyl, so ruled out. They do not contain the carbonyl group. The probable structure is of the B or D. The PMR spectrum shows the peaks delta 3.59 singlet to hydrogen. This is a singlet. In respect of two hydrogens, we do not expect to observe it in structure D because protons on carbon 1 will give a quartet, protons on carbon 2 will give a sixlet, and protons on carbon 3 will give a triplet. Hence, structure D is ruled out. Whatever is structure D, singlet. This is singlet is spectral 2 hydrogen. We do not expect observe it in the structure D because protons and carbon 1 will be quartet. We will give the sixlet and the triplet. Structure D. Quartet. This one quartet. This one sexlet. This one triplet. The only structure left is B. Protons, carbon 2 will give singlet. This will be no splitting of peaks as there is the no hydrogen on the neighboring carbon, and structure B is confirmed. Carbon 2. B carbon 2. Okay, the only structure left B. Protons on carbon 4 will give a singlet. There will be no splitting of peaks as there is the no hydrogen neighboring carbon, and structure B is confirmed. C. 7.22 singlet 5 hydrogen. For 5 aromatic non-substituted benzene, delta 7.22 singlet 5 hydrogen. For aromatic, delta 7.22 5 hydrogen singlet for aromatic. Delta 3.59 singlet 2 hydrogen. Delta 2.59 2.59. Okay, this is the 5.59 singlet 2 hydrogen. Delta 2.77 quartet 2 hydrogen. Delta 2.77 quartet 3 neighboring, so quartet. Delta 0.97 delta 0.97 7 is the methyl. So structure B is correct. In organic compounds having the molecular formula C4H8O gives a characteristic band at 275 nanometer Emax Chatra. In UV spectrum, its infrared spectrum with two important peaks at 2940 to 2850 per cm and 1715 per cm. EMR spectrum of the compound is plus delta 2.5 quartet 2 hydrogen, delta 2.12 singlet 3 hydrogen, and delta 1.07 triplet 3 hydrogen. Assign a structural formula to the compound. The compound shows a UV absorption at 275 nanometer. This absorption is characteristic of carbonyl group. IR absorption peaks at 2940 to 2855 per cm is due to CS stretching of methyl groups and saturated ketonic groups. With the formula C4H8O, there are two possibilities, aldehyde or ketone. Formula first is the rule out as it contains 4 types of protons and would give the 4 signals, which is not in the agreement with data. The structure left the ketone and there are 2 types of protons and 3 of second and 3 and third type will give rise 3 signals. C2 protons will give a quartet, delta 2.5. C4 protons will give singlet, delta 2.12. And C1 positions will give a triplet observation made with the structure. Second will agree with data. Two point seven, but carbonyl. So it may be aldehyde or ketone. Higher absorption 2940, 2855 per cm. CH. From the NMR, there are the 1, 2, 3, 4 types. In case of first 1, 2, 3 types. 1, 2. Quartet, singlet, triplet, quartet. This possibility singlet, quartet, triplet, triplet, quartet. Triplet. Duplet. Okay, doublet. The data. Quartet. Singlet. Triplet. Quartet, singlet, triplet. No duplets. The possibilities ruled out is the context for fast proton and give 4 signals. 4 times. Basically, 1 CS2 is two. Okay, 1, 2, 3, 4 times. Okay, good. Formula is wrong. 1, 2, 3 times. Okay. Formula 1 is the rule out is the contains 4 types of protons and would give the 4 signals which is not agreement with data. Structure left is that second there are the 2 types of protons, 1 type and 3 of second, 3 of third, and give rise the 3 signals. C2 singlet delta 2.12 2.12 quartet 2.5 quartet is this one 3 quartet 2.5 2.12 1.7 forward. Okay, methyl. So correct structure is structure second. Okay. It's all about some spectroscopic problem solving. Thanks for watching and request you all like, comment, share, and subscribe. Thank you for your patience. That's now bye bye. See you again.